This is another question based on ratios. And this question is a very time-consuming one if you solve it traditionally, the calculation part especially. Okay, so we'll see the traditional method. We won't do the calculation. We'll just see what would be the approach. And then we'll see how we could have made it much easier. So we have the ratio of the number of coins in boxes A and B was 17:7. After 108 coins were shifted from box A to box B, this ratio became 37:20. The number of coins that needs to be shifted further from A to B to make this ratio 1:1 is how much? So what most people would do here, they would start with the total of A and B, where we have 17:7. So they would take 17x for A and 7x for B. Variable, of course, because since we have actual number of coins, we have to find actual number of coins. We have to deal with actual values. So we'll take a variable. Now, once we've taken total for A and B, now we have 108 coins shifted from A to B. So A's will reduce by 108 and B's will increase by 108 after the shift. So A will become 17x minus 108. B will become 7x plus 108. And now the ratio is becoming 37:20. So this ratio is equal to 37:20. Okay, now we'll have to convert to fraction and solve. Basically, if you look at it this way, this 20 will be multiplied with this, which will be equal to 37 into this. Now, of course, the calculation part will take some time because we'll be dealing with relatively large numbers. And even if you are fast in calculation, even after you do this calculation to find the value of x, that still won't be the answer. For the answer, we need the number of coins that needs to be shifted further from A to B. So we'll have to find these two values and then see how many coins have to be shifted from A to B to get the ratio 1:1. Okay, so not very convenient. So before we come to the best method, here if I still show you a method with variables, we could have made this slightly more efficient by thinking that, okay, we need to focus on this situation. Okay, from here, how much has to be shifted from A to B to get 1:1? So here, rather than having minus 108 and plus 108, here we could have thought that we already know the ratio for this. We already know 37:20. So here we could have taken 37x and 20x. And this would have been easier because now we can very quickly see that 37x and 20x, the average, 37x plus 20x by 2, 57x by 2, that would be 28.5x. So we could have thought that if we want to make them equal, then A has to reduce by something to become 28.5x and B has to increase by something to become 28.5x. Then they will become equal in the ratio 1:1. And of course, then we can see that 20x to 28.5x, that is an increase of 8.5x. And similarly, this will be a decrease of 8.5x. So now, easily we can see that we just have to find out this value 8.5x. That is how much is being shifted from A to B to get the ratio 1:1. And now, at the beginning, whatever we had in A, that was reduced by 108. 108 coins were shifted from A to B. Then we got 37x. So initially, A must have had 37x plus 108. Similarly, B, the number of coins were increasing by 108. After the increase, we got this. So before the increase, we would have had 20x minus 108. And then what we can do is we can say that these two values, initial number in A and B, are in the ratio 17:7. And we can solve that fraction. Okay, we can solve that equation. We can get the value of x. And then we will just have to calculate 8.5x. That will be the answer. So while this is better, okay, this is slightly better than the previous one, still we will have to deal with this particular equation. And still we'll be dealing with relatively large numbers, which will take some time. So let's look at an even better method where the calculations will be easier and we won't even have to take any variables. So for the better method, we have to see, in fact, we have to think that the total number of coins in A and B combined is remaining the same. If you look at A and B together, what is happening is 108 coins are being shifted from A to B, but the total of A and B is still the same. It's just from one box you are shifting to another box. Okay, so if you focus on that part, that the combined total is still the same, then you can think that, okay, A we had 17 and B we had 7. At the beginning, 17:7. And then after the shift, we have 37:20. Now, here the total number of parts, 17:7, 17 plus 7, that is 24. And here the total number of parts, 37 plus 20, that is 57. Now, we want to make these two totals equal, because ultimately before the shift and after the shift, the total in A and B combined has to be the same. So to capture that logic, we need to represent these totals with the same number. So of course, we'll take the LCM. We don't really have to calculate the LCM. We just have to think, okay, 24 is 3 into 8. Now 57 has a 3. And it also has a 19, 3 into 19. So here we need to multiply this with 19. And then we need to multiply this with 8. Because see, if we multiply this with 19, and then 57 with 8, then the totals will become the same. That will give us the LCM. Okay, so if we can do that. But we don't have to look at all the values. Let us just focus on any one of them, for example, B. So if we just look at B, here this is being multiplied with 19. So B will become 7 into 19, which is 133. And here this will become 24 into 19. Which is 456. And here, this is being multiplied with 8. So we'll get 20 into 8, which is 160. And 57 into 8, which is again, of course, the same thing, 456. That is the LCM of the two values that we took. See, now, of course, these are not the actual values. We'll come to the actual values. But at least we are satisfying the condition that the total is remaining the same, combined total. Now we can see that B, from 133, it is increasing to 160, which is an increase of 27 here. But we know that increase is not actually 27. It should be 108. 108 coins are being shifted. So now we can think that the relationship between our assumed value and the actual value is the relationship between 27 and 108. So if we want to go from our assumed value of 27 to the actual value of 108, we have to multiply with 4. Okay, so we'll keep that in mind, that this is the adjustment multiple. And we have to multiply with 4 to get to the actual value. Now, we have 160 for B here. And the total is 456. Now, if we want the ratio 1:1, that means A will get half of the total, B will get half of the total. So B will have to get half of 456. 456 by 2, that is 228. So from 160, B will actually have to get 228. Okay, 160 to 228, that is an increase of 68. So we are getting that increase of 68 for B, which means 68 coins will be shifted further from A to B, so that B increases by 68. But this is our assumed value. The actual value will, of course, be 68 into 4. So once we calculate that, we will get 68 into 4 to be 272. And that will be the correct answer. So even if you had solved using variable, using the previous methods, you would have got 272. But of course, the calculation would have taken time. Now this method, no variable, calculations are much easier. Of course, this is slightly more complicated conceptually. But it's a very good method to know, especially in these situations when the totals, the combined total is remaining the same. Okay, so practice this. And to help you practice, you can use this replica question. Make sure that you share your answer in the comment section.